So you just heard me mention kind of talking about how frequency and wavelength are related. And that's exactly what I want to talk about here. The relationship between frequency and wavelength. Obviously, it's a pretty simple one. If you look at, I almost would rather have the same amplitudes just so you can see. So let's do the same amplitude. Notice the frequency here and wavelength, how they're related. These are your wavelengths in the red, and obviously the wavelengths are different. We get a certain distance on the left one and a certain one on the right. The lower, and geez, I don't like that red. This is a bad background here. Whoops. Get out of that. So the lower, the shorter the wavelength, the higher the frequency. And again, the longer the wavelength, the lower the frequency. And again, it just makes sense. So if you have waves that are going to be that much more compressed, the wavelengths are shorter, then they're going to oscillate up and down. Now, if we talk about the speed being the same, so the speed of light, so that speed, whether it's going or even faster, from it to get to from one point to the other, it's the same because the speed of light is a constant. Then if there is light that has a higher frequency, then it needs to be moving a little bit, it's moving the same speed. It's going at the, it's got a shorter wavelength, but a higher frequency. So these relationships between frequency and wavelength, considering we do have constant speed of light, can be looked at in a formula, okay? Now, I do remind people that this is an inverse relationship. There you go. Inverse relationship, meaning as one goes down, the other one goes up, or as one goes up, the other one goes down. It's inverse. Direct relationship, of course, as one goes up, the other one also goes up. So there's the relationship. Now, how can we define that? Well, because the speed of light is constant, and because light has different, you can break it down into different colors being different wavelengths, then therefore there must be some kind of formula that we can use. And there is. The formula is speed of light is equal to the frequency and wavelength multiplied together. So if you multiply the frequency and wavelength, since as one goes up, the other one goes down, right? If low wavelength, short wavelength, we've got a high frequency versus the opposite, then you're going to be multiplying one low number by a high number or one high number by a lower number, then that equals the constant. So it makes sense that we have the speed of light is a constant, frequency and wavelength multiplied together. Now, to solve one of these problems, okay, the speed of light is a constant, it's always 3.00 times 10 to the 8th meters per second. That's a constant, we got to know that. If you're given one of the other variables, either the wavelength or frequency, then you might just need to rearrange algebraically the equation and then solve. So I want to go ahead and do that. Now, what's important before I even do that is to know how to type into your calculators. We've got this times 10 to an exponent, okay? On your calculators, you can type in the little 3.00 and then hit times and then the 10 and then carets and all those types of things. But your calculators, all scientific calculators, are going to have either an E key or an EXP key. Okay, most calculators have the EE, you might have to hit second function, EE key or the EXP key. And in order to type this in, all you would need to do is go 3.00, of course you could just go 3, but 3.00, EE or EXP. Don't hit the times and then the EE, times 10 EE. It's just this one key. EE means times 10 to a power. So you would just have to hit 3.00 EE 8. 3.00 exp8. And I need to grab my calculator. So I can go ahead and solve this. But that's how you would type it in. And again, it's important to remember. So let's go ahead and let's say I give you a wavelength and I want to solve for this. So if I say that your wavelength is 5.25 times 10 to the negative 7 meters, and I want to know what the frequency is, okay? The formula is right here, speed of light, and again, remember that the speed of light is a constant, 3.00 times 10 to the 8th meters per second. Let's go ahead and solve this. Now, I'm a big fan of rewriting my equation first, so I want to solve for frequency, and so there it is. Frequency is equal to C over the wavelength. Of course, all I did was divide both sides by the wavelength, and I canceled on the same side with the frequency, and then I have this. Now, I just need to plug and chug. Solve for my frequency is 3.00 times 10 to the 8th meters per second over 5.25 times 10 to the minus 7 meters. Okay, and again, I'm a fan of taking that equation that you do know, that formula, rewriting it, taking the numbers that you know, plugging it in, and then you can just solve. So my calculator is now on 3.00. I hit my EE, that's it, EE8. Then divided by 5.25. I have to hit second function, but all I'm doing is EE, negative 7 equals, and there's my answer, 5.71 times 10 to the 14th. And the label for frequency is 1 over S, cycles per second. I like just leaving it as 1 over S. You can put hertz, but I like 1 over S because notice my meters get canceled. And because this was meters per second, and if the meters get canceled, you get 1 over S. So there would be your formula, and therefore the solving for this relationship between frequency and wavelength.